Hey guys, this is Coach Brian with page 2 of your final exam review. For question number 4, we're dealing with reference angles. And the way I described reference angles in class was think of them as the fastest way back to the x-axis. Fastest way back to the x-axis. All right. So what do I mean by that? I mean, these angles lie in different quadrants. And, if you're in quadrant 1, the fastest way back to the x-axis is going to be to just return to it, okay? If you're in quadrant 2, okay, you're going to just take the fastest route to the x-axis. And same is true for all the other quadrants. If you're in 3, you're just going to go back. If you're in 4, you're just going to go back. Now, think about what values lie on the x-axis. You have 0, you have pi, and if you make a full circle, you have 2 pi. So really, the reference angle is either going to take an angle that's not quite 90 up here. Let's say this is like 45 degrees. It's going to take you back down to 0. But this one isn't quite 360. It's going to bring you to 2 pi or 360. This one's not quite 180. It's going to get you the rest of the way there. This one's not quite 360. It's closer to 180. It's going to bring you back to 180 or to pi. So for this particular question, it says, which of the following two share the reference angle of 3 pi over 7? So 1, remember, the reference angle is always positive. Okay, reference angle is always positive no matter where you are. And so think about it. Which two of these choices to either get to pi or to get to 2 pi would need another 3? Okay, really think about this. Which ones would need another 3? If you're not sure, you could always graph them out. I'll do that really quickly, just to be thorough. And by graphing them out, you should usually be able to tell pretty quick. All right, let's start with A, 9 pi over 7. So we're going to label our axes. We got 0 there. Since these all have a denominator of 7, I'm going to make this side 7 pi over 7. Halfway then is going to be 3.5 pi over 7. That's kind of a weird angle. The other half is going to be 10.5 pi over 7, also a weird angle. And then to make a full circle will be 14 pi over 7. So let's think about where each of these lies. 9 pi would be over here, and its reference angle to get back, I would need to take away 2 pi, so that would be my 2 pi over 7. That's not it. Let's look at B, negative 4 pi over 7. All that means is I'm going this way. I'm going 1 pi. Oh, I don't want a straight line. I'm going 1 pi, 2 pi. I'm trying to get I'm getting 3 pi. All right, 3 pi over 7. I get to 4 pi over 7, and I'm somewhere a little over halfway. I'm like right here, okay, for negative 4 pi over 7. Now, the reference is the fastest way to the x-axis, which is just to finish going the rest of the way. Finish going the rest of the way up. And I'm at negative 4, trying to get to negative 7. How many more radians do I need? I need 3 pi over 7 to get the rest of the way there. That's my reference angle. Now, just plain pi over 7 is somewhere over here. Okay, pi over 7. And its reference angle, it would just be getting right back to the x-axis. So its reference angle, when you're in quadrant 1, is the same. It's pi over 7, not the answer. All right, negative 14 pi over 7. Hopefully you can eliminate this one quickly because 14 pi is a full circle. Negative just means I'm going, we should stop doing that. Negative just means I'm going this way around the circle. And if I make a full circle, I'm right back on the x-axis, so my reference angle is nothing. And then lastly, I've got, I'm going to redo that. Lastly, I've got 11 pi over 7. Now, if you're using process of elimination, yes, this one's right. But also, if I went 11 pi over 7, see right here, I've got 10.5. 11 would be somewhere right here. All right, 11 pi over 7 would be somewhere over here. And to just finish the job, to just go the rest of the way, would need another 3 pi. So that would be my reference angle. Question number 5 says, if angle theta, that's a clue right there. Theta, I'm using degrees. Okay, I'm using degrees. It says it terminates in quadrant 3. Okay, let's do this. Q3. When you're in Q3, this is all from the question I answered earlier in part 1. When you're in Q3, your x and your y are both negative because you had to go left and you had to go down to get there. The other thing, if you remember, all students take calculus. The only things that will be positive here are tangent, all right? Sine and cosine should be negative. So let's actually check this out. Right now, they give us the secant. Secant is the reciprocal of cosine, which means, because cosine is x over r, it means it's going to be r over x. So what they've given us here is that r is 17 and x is negative 8. And if you're wondering, like, how did you know that the 8 was negative and not the 17? R is always positive. Just like on the unit circle, it's always positive. So also think about the x. I had to go left, so I had to go negative 8. So what we've got here is a triangle down in quadrant 3, okay? And we know that the x is negative 8, and we know that r is 17. So what we need here to really find all these ratios is we also need the y, okay? This is a right triangle, and we're looking for a side. So we could use the Pythagorean theorem. We could use a squared plus b squared equals c squared. And we know a, we could say negative 8 squared. We don't know b, that's our other side. And we could say that equals 17 squared. As we're working this out, we've got 8 squared is 64. Still don't know b squared. And 17 squared is 289. So we're going to move over our 64. And that's going to leave us 225. So b squared is 225. Now at this point, if you remember a lot of your common perfect squares, that means this side is 15. But remember, we're going down 15, so it's negative. It's negative. So we have all of our sides here. We have our x, our y, and our r. Now it's just time to fill in the blanks. Sine is y over r. So we're going to take our y, negative 15. I've already got my negative here. And put it over r. So negative 15 over 17. Cosine is x over r. So we're going to take our x, negative 8. I've already got the negative here. And we're going to put it over r, 17. And then lastly, we're going to get our tangent. Tangent is y over x. So in this case, I've got a positive out here, but x is negative 8 and y is negative 15. Or excuse me, I wrote those backwards. I wrote x and y. Sorry. Y is negative 15, x is negative 8. Negative over a negative equals a positive. Remember, in Q3, all students take calculus, so tangent will end up being positive because you have a negative x divided by, or excuse me, a negative y divided by a negative x, and they will give you a positive result. All right. Which two of the following expressions are equal to cotangent theta? So this is kind of getting into our trig identities now. Cotangent, if you have your hexagon, whether it's in front of you or you've just used it so much that you remember it, there's a few ways we can write cotangent. All right, if you have your hexagon handy and you remember that the first thing equals the second divided by the third, we could write cotangent a number of ways. We could go straight across and we could get cotangent equals 1 over tan. We could go counterclockwise and you would get cotangent equals cosine over sine. Or we could go clockwise and you would get cotangent equals cosecant over secant. So a lot of different ways we could write cotangent. Now let's see if any of them match our answers. It says that there are two of them. It's A, that matches. It's not B, that's tangent. C matches, and it's not D. Tangent and cotangent are not equivalent. All right. Question number 7. Lottie can see two airplanes from where she is standing. One is 6.2 miles away and the other is 9.7 miles away. The angle between them is 60. What's the distance between the two airplanes? Round to the nearest thousandth. So to help you, let's sketch this out. Here's Lottie right here, and she sees an airplane over here, and she sees an airplane down there. Okay? Now, these airplanes, from her, one of them is 6.2 miles. The other one's 9.7 miles. And the angle between them is 60 degrees. So let's look what we have here. We have a side angle side situation going on here. And we want to know the distance between the two planes. We're looking for a missing side here. Okay, we're looking for a missing side here. Now, based on the information we have, side angle side, we could use the law of cosines. Now, you will be provided this formula, but you maybe have used it so much, like me over the last couple of weeks, that you have it kind of burned into your brain now. So we use law of cosines when we have side angle side, and we can use it to find a missing side or a missing angle. Now, in this case, we're looking for the missing side, which is nice because everything is already set up exactly how I need it to solve. Now, I'm going to start with this step. You see how this A is squared? I'm going to, no matter what, have to end up square rooting the entire right side. So I'm going to do that first, and then I'm just going to plug in all the other numbers I have. So let's go with side B. Which one's side B? Doesn't really matter. Pick one of the sides. I'm going to go with 6.2. Make sure you square it. If I made 6.2b, that means C has to be 9.7. Make sure you square it. Now, one thing I like to do, especially if I'm about to type something in the calculator, is I like to overuse parentheses. So I'm going to put that thing in parentheses. And now the next step is I'm going to subtract 2bc. Well, since 2b and c are being multiplied, I'm going to go ahead and put that in parentheses also. 2 times 6.2 times 9.7. And I'm going to close that parentheses. And then the last thing is I'm multiplying by cosine of my angle. So cosine of 60. Now, first thing that you need to check before you do anything with your calculator, this angle was given to us in degrees. You need to make sure that your calculator is in degree mode, okay? Now, you can as I have written this on the screen, this whole thing right here, you can type that directly into your calculator, hit enter, and it will tell you that side A is 8.508 miles. How did I know it was miles? Because that is what the side lengths given to me were in. So I'm going to keep my answer consistent with that information. Question 8 says, simplify the following to a single trig expression. So what I've got right here is I've got secant over sine minus sine over cosine. So the first thing here is I need to realize that I am subtracting two fractions. They must have, to subtract, they must have a common denominator. So what you need to do is you need to say, what does this denominator have that this one needs? And what does this one have that this one needs? So the first fraction, secant theta over sine theta, is missing cosine. So how do I remedy that? I'm going to multiply it by cosine over cosine. That's just a fancy way of multiplying it by 1, but it allows me to rewrite it as secant theta times cosine theta over sine theta times cosine theta. For my second fraction, I've got, don't forget your minus sign, I've got sine theta over cosine theta, and what it's missing is sine. So I'm going to multiply it by sine theta over sine theta. Again, that's just 1. I'm multiplying it by what we call a clever 1 so that I can rewrite it with a common denominator. Sine times itself is sine squared theta. Cosine times sine is sine theta times cosine theta. Now, do you see these have a common denominator? Yes, they do. So what that means is I can squish them together into 1. Now, I am running out of room, but it's still not as simplified as it can be. I'm trying to write it as a single trig expression. So I've still got work to do. Using your hexagon and just hopefully your knowledge at this point, you'll remember that secant and cosecant are reciprocals, which means, I'm gonna take my work this way now. They are reciprocals, which means when you multiply them together, they give you 1. So I can rewrite the entire numerator as 1 minus sine squared theta over sine theta cosine theta. Now, I'm still not done. This looks suspiciously like one of the Pythagorean 7s. And if you rearrange sine squared plus cosine squared equals 1, you'll see that you can rewrite this. You can rewrite this as cosine squared theta over sine theta cosine theta. Now, again, I'm running out of room. I'm going to, I know this always annoys y'all in the videos, I'm going to shrink some work here. And that didn't really do what I wanted. Hold on. How can I better select this? I'm going to erase that, pick all this, and close enough. All right. Move that over there, make it a little smaller again. There we go. That works for now. All right, so where I'm at, picking up here, where I'm at, I've got cosine squared theta over sine theta and cosine theta. Now, some of you are good at canceling this out as is, but if you don't feel comfortable canceling things out, you could go ahead and rewrite this. See how that's squared right here? That means it's cosine theta times itself. That's all that means. And then you've got that over sine theta times cosine theta. So we're getting really close to being fully simplified here. What we need to do is just cancel out that cosine. What we're left with is cosine theta over sine. And one last time, if you remember first equals second over third, you can use your hexagon and you can even simplify this further to cotangent of theta. So we were able to take this entire beginning expression and simplify it all the way down to cotangent. Now for question number 9, it says which two of the following, so we know there's two right answers, which two of the following are equivalent, which two are equivalent to cosecant squared theta minus 1 over cosecant squared theta. Now, for this one, can I rewrite anything? Can I rewrite anything? The answer is yes. You can rewrite. First, looking at this numerator, it looks suspiciously like one of the Pythagorean identities. And if you use your hexagon, the one that involves cosecant is 1 plus cotangent squared theta equals cosecant squared theta, okay? Now, can I make these two things match? Can I make these two things match? I can. See how I can just move the 1 over? And now I have cosecant squared minus 1. What I've done is I've made these two match. What that means is if they match, that they're equivalent, and that means I can substitute cotangent squared theta as my numerator. So let's do that. Cotangent squared theta over cosecant squared theta. And as you do that, hopefully you realize that is answer choice A. So A is one of the correct answers right there. Now, doesn't match any of these others yet. So what I want to keep doing is I want to see if I can keep simplifying. So the next thing we've talked about a lot in class is if you're not sure where to go next, rewrite in terms of sine and cosine. So let's start with cotangent. Cotangent equals cosine squared theta over sine squared theta. And that would be divided by cosecant, which is the reciprocal of sine, so I could write it as 1 over sine squared theta. So hopefully y'all are starting to see how this is going to unfold. I need to keep, change, flip, which means instead of dividing, I'm going to multiply. And instead of 1 over sine squared, I'm going to flip to sine squared theta over 1. And as you can see, as I multiply, these two cancel out, and that leaves me with cosine squared theta, which is answer B. So A and B are equivalent to my original trig equation. Hopefully this helped you, and I will be bringing you page 3 in part 3. Thank you.